Hello students, this is Unit 1, Lesson 9, Piecewise Functions, and I'm going to combine graphing piecewise functions and evaluating piecewise functions in the same lesson. So this concept is business math. This is a business math concept, and we usually, when you're in business for yourself and you're charging people for your services, you want to base that on a piecewise function. I'm going to give you a real world example. The prices aren't exactly the same as what I charge, but I'm going to give you this example that is a piecewise function. So up until a couple weeks ago when I sold my trailer, I moved horses for people. And so let's say somebody called me and said, I need my horse moved, can I get some prices? I might say, okay, well, up to 20 miles, as long as you're local and it's not a big stretch for me to get to where you are, up to 20 miles for local hauls, I charge a flat rate of $100. So I would say, but that's only up to 20 miles. Anything over that, I charge more. So that function, if I wanted to put that in a function, that would be y equals 100, because up to 20 miles, everything, no matter what x is, no matter how many miles it is, up to 20, I charge $100. So even if it's 1 mile, I still charge $100. But the restriction that I would put on that is anything 20 miles or less. So if x is less than or equal to 20 miles, charge $100. If it's over 20 miles, up to 80 miles, let's say, I charge $3 per mile. So anything from 21 to 80 miles, it's $3 per mile. Well, if I wanted to put that in a function, that would be a linear function, 3x. And I would write my restriction out here, or my miles restriction. I would put, okay, 20 is less than x. I don't want to put equal to, because my 20 is included in this part. So x is greater than 20 and less than or equal to 80. So over 20 miles up to 80, I charge $3 per mile. So once I got to that part, if somebody said, well, if a person said, well, I need my horse hauled to Knoxville, Tennessee. Okay, well, Knoxville, Tennessee is 240 miles. So in that case, I charge $1 per mile, which is not true. I charge more than that. I charge $1 per mile plus a flat fee of $50. So that would be in a function, that would be still linear, but $1 per mile would be 1x, and then plus that $50 that I would charge up front for me to hitch up my trailer. And that would be if x was greater than 80 miles. So anything over 80 miles, I would charge $1 a mile plus $50. I mean, it kind of makes sense if you think about it. If I only charged $100 flat rate for anything, well, that'd be kind of dumb, because if somebody needed me to haul their horse 1,000 miles and I only charged $100, that would be stupid of me. Same thing up here, though. If I only charged $1 per mile plus $50, what if they wanted me to haul their horse, I don't know, 18 miles or whatever? Or if I only charged $3 per mile and they only needed their horse hauled 3 miles, well, that'd be $9. I'm not hitching up my trailer for $9. So anyway, that's why it's important sometimes when you're in business to set up a sort of a tiered pricing system, so that you feel like you're getting your money's worth and the customer is charged a fair price. Now let's look at this. If I were, I'm gonna see if I can delete this square. There we go. Okay, so the blue function, the y equals 100, is represented by this blue line, or this blue ray right here, because it does stop right there. So that blue ray is the y equals 100. So no matter what x is, y is 100. Okay. The y equals 3x is represented by this red ray right here. And then the y equals x plus 50 is here. So I had a y-intercept of 50, and then I did a slope of 1 all the way across. As you can see, this is not a function. So, but that's because I graph these functions without taking into account these domain restrictions, or the mile restrictions. So if I take into account the mile restrictions and I go back over here and I say, well, this blue one that was up to 20 miles. So let me, you know what I'm going to do? I'm going to draw a line here. Let's draw a yellow. Let's just do a yellow line that shows that 20 miles right here. So this is the 20-mile. Oops, I wanted yellow. There we go. Let's try that. So I want to know that up to 20 miles, that's my blue function. And then from 20 to 80 is another function. So let's go to 80. I'm doing it in yellow just so it's not too dark. So my red function should be between these two numbers. And then my green function is over here, is everything over here after 80. So let me take my blue line and see if I can back it up. There we go. To where it's just up to 20 miles. And then my red one is supposed to be between 20 and 80. So let me see if I can, that one goes above 80, so I don't need to do anything with that, but it would meet the 80 somewhere up there. So let's see, let me move this one up to here. Well, and then the green one is just everything over here, so I need to move this one. So if I did that, if I took away parts and just included the parts that were within these restrictions, then that would work. This would be a function, but I still need to look at the blue one and the red one and figure out what I'm doing here, because there's 2 points right now that are in the same vertical line. So the blue one included 20. So what I would want to do then is take my blue marker and make a closed circle or a colored in circle here, but the red graph, the red function does not include 20. So I would take my red and be sure that I did an open circle there. That way I've got a closed circle and an open circle in the same vertical line, so it's still a function. It still passes the vertical line test. Now with the red one up here, I can't see where it meets that yellow line, but the red one at the 80 would be a closed circle. So I'm just going to draw a closed circle there. So up there somewhere there would be a closed circle. The green one is above 80, so it does not include the 80. So that one would have an open circle right here. So that's just a little crash course on what piecewise functions look like and how they work. I'm going to do some examples with you, and we're going to graph some together. I'm going to kind of show you some shortcuts for graphing piecewise functions, and then we're going to talk about the domain and range of the piecewise functions. So we are starting on page 24 of your notes, and we're going to just kind of give a little loose definition of a piecewise function. Piecewise means that it is parts of different functions that have been cut and pasted together without overlapping. So just like the one we did over here, where we've got the different parts of them, we had the whole thing, but then we just had to back it up or put it where it needed to be. That's what we do. We cut them and paste them together, or we take off the part that doesn't work, that doesn't meet that domain restriction. Okay, so look at number 1 and understand that this is a function and this is a function. These things over here, these are called domain restrictions, just like the up to 20 miles thing. So there are some kind of shortcuts that we can take, or so that we're not making XY tables all over the place. I'm going to show you kind of the steps of how I do this, and we're going to graph some of these together. So number 1, I pretty much always use different colored pens. So if you want to pause the video and grab some different colored highlighters or markers or pens or whatever, it might be helpful to you as well. I also always draw like that dividing line like I did with the yellow a while ago. So I'm going to use like lighter colors for that. So let's use blue. We're going to graph this part of the function first. And what we're going to do is we're going to, first of all, figure out where that dividing line is for this one. The dividing line is at -2 because it says x plus 3, in this sense, this is like if or when x is less than or equal to -2. So I'm going to take my line tool and I'm going to make a yellow line at x is -2. So at x is -2, I'm going to make a line because that's where that dividing line, so to speak, is going to be. So this part of the graph is going to be to the left of this line. It's going to be over here because it's everything that's less than or equal to -2. The next thing I'm going to do is I'm going to decide, okay, I'm going to use blue for this one. So I'm going to use blue here. So I'm just going to put a circle here. And then I'm going to look and say, okay, I've got that equals marks. So that means there's going to be a closed circle somewhere on that -2 line, that x equals -2 line. I just need to figure out where it's going to be. So what I'm going to do is I'm going to make an ordered pair using the -2. So the -2 is going to be my x. Might as well find out where on this line that closed circle is going to be. So if x is -2, plug in -2 right here. So -2 plus 3 is going to give me my y. So -2 plus 3 is 1. That gives me my ordered pair. So -2, 1 is right here, and that is where that closed circle is going to be. So I'm going to go ahead and put it there. Okay. My function is x plus 3. So that's linear. It would have a y-intercept at 3, but the y-axis is not in this function. So I'm not going to put my y-intercept there, but I can count a slope from anywhere on a line. So I know that the slope is 1 for this one. So I can start here and count up 1 over 1. Here's the problem. With that, if I count up 1 and to the right 1, I've gone into the part of that graph that can't include this function. So I don't want to go up 1, right 1, but I can go down 1, left 1, and that'll still be a positive slope. So if I do that, down left, down and to the left, and I can do that as many times as I want to, and then I'll take my line tool and go from this point and make that slope and then put an arrow on the end of it. So that's the part of the graph that is x plus 3 if x is less than or equal to -2. All right, let's look at the next one. Let's use red for this one. Okay, so this time I'm going to use red. I'm going to go ahead and draw a circle here to indicate I'm using red on this one. And then I'm going to look at this symbol right here to decide whether to color it in or not. Well, I don't have that equals down here, so I'm not coloring this in. This one's going to be an open circle. Now I need to figure out where that open circle is going to be. I'm going to use my -2 again. So -2 divides both sides of this graph. This one's two sides. -2. The way I figure out what the y value is, plug in the -2 right here. -2 times -2 plus 5 will give me my y coordinate. So that's 4 plus 5, that's 9. So at -2, 9, I'm going to put an open circle. -2, 9 is way up here. Open circle. Okay, what's my slope? My slope is -2. Slope is -2. That means I'm either going to go up and to the left, or I'm going to go down and to the right. Well, the only one that's going to work for this is down and to the right, because this graph has to be over here because it's everything that's greater than -2. So when I go from here, I'm going to go down to the right one. And then I'll just do it again one more time just so I have 3 points. So I can make sure it's looking right. And this one's red. So I'm going to go from this original open circle down this way, and you can draw it all the way down here if you want to. It doesn't matter. You're going to put an arrow on the end of it. Okay, and that's my piecewise function. This is a two-part piecewise function. Okay, now we're asked for the domain and range. Well, this one happens to go to the left forever and to the right forever, and it doesn't miss any points. So the domain for this one is all real numbers or negative infinity to positive infinity. What's the range? It does come from negative infinity, so I can start with that. It stops, though, at positive 9. And positive 9 is not included because it's an open circle, so that would be parentheses. Okay, so let's see if we can move a little bit faster through the next one. As long as they're linear functions, it's really easy to do. You just do it the same way every time. Let's find the dividing line. The dividing line is going to be at positive 4. One of them is less than positive 4, and one of them is greater than or equal to. So let me draw that line at 4, which is right here. Just helps me kind of keep track of, okay, one's on this side and one's on this side, because they can't be on the same side. So let's use, I'll go with purple. This one has an open circle because it's just less than. And my ordered pair is going to be 4 something. Okay, so I'm going to use this because that's where that dividing line is. So I want to know where that open circle is going to be. So 4, I plug in for x. 2 times 4 minus 4, that's 8 minus 4, so that's 4, 4 is where my open circle is going to be. So let's do that. 4, 4, put an open circle here. All right, now let's look at the slope because we can do slope from anywhere. We know that this graph is going to be to the left of the yellow line. So we just need to make sure that when we do the slope, it goes to the left of the yellow line. So our slope is 2. I can't go up 2 and to the right one, but I can go down 2 and to the left one. So there's 1 point, down 2, left. So let's join those points. So it's going to look something like that. Put an arrow on the end of it because it does keep going. Okay, next one, we'll do green. So this one, draw my circle. It is a closed circle because it's equal to. And then this one is going to be to the right of the yellow line because this one is greater than or equal to. So I'm going to use 4 again as my x value. Now I need to plug in a 4 here. So negative 3/4 times 4, which is 4 over 1, plus 11. My 4's cancel. So that's negative 3 plus 11, which equals 8. So my y value is 8. So let's go to 4, 8, and closed circle this time. This one needs to go out this way because it's greater than. So my slope is negative 3/4. So that means I can go down 3 over 4. 2, 3, 4. And that's the only one I can construct. So let's just join the closed circle and that point, and that'll be good. So there's the other side. And we'll just check it out and make sure I've got a closed circle and an open circle in the same vertical line. So that works because this is not included. So it still passes vertical line test. Domain, it is still all real numbers because there's no break in this graph. The range at the bottom, it does start at negative infinity. It does have a stopping place at the top, and that is 8. And 8 is included in the graph, so we're going to use a bracket. Okay, so number 3 is a 3-parter. So I've got 3 different functions, a couple of different lines that I'm going to want to go, actually no, it's 3 lines. So let's just take it one function at a time. I think what I'll do though is I'm going to do the middle one first because I think that these are actually easiest to do. Let me show you what that means. So my lines that it's going to be in between are negative 3 and 3. So I'm going to draw lines, yellow lines at negative 3 and 3. Okay, so I've done that. I've drawn my lines at negative 3 and 3. Now, this has a, I'm sorry, wrong one, x plus 5. Okay, so I have 2 different points that I want to look at. Let's do green. My first point is the -3. I have my equals here, so I'm going to have a closed circle somewhere on that -3 yellow line. And then I'm going to have an open circle on the +3 yellow line. How do I know where it's going to be on that line? I make an ordered pair. Make an ordered pair with -3. Plug it in right here. -3 plus 5 is 2. So my closed circle is at -3, 2. So let's do that. -3, 2, closed circle. Okay. My open circle, I don't have room right here, so we'll go down here. My open circle is at 3 something. Plug in a 3 here, 3, 8. Okay. So 3, 8 is up here, and that was an open circle. Now, it's everything in between -3 and 3. And so I've got my 2 points here. I could graph, you know, I could go 1, 1, 1, 1, whatever, I don't care. I just need to join these 2 points. So this is what it looks like after I join the 2 points. All right, so let's look at the top section. X equals -2 everywhere that X is less than or equal to -5. So my -3 is not my dividing line here. It's going to be at -5. So I'm going to construct another line here at X equals -5. Okay, so I did that. Now, I need to know where on this -5 line my closed circle is going to be. I'm going to do this one in blue. Closed circle. Where is it going to be? -5. There's nothing to plug in over here. Everything is -2. It doesn't matter what X is, Y is -2. So what that means is at -5, -2, I do have a closed circle. And if Y equals -2, it's a horizontal line. So I'm just going to construct a horizontal line to the left of this closed circle. So there is that part of the graph. Okay, the rest of the graph is this one right here. Let's do that one in red. So we'll do that one in red, and that's going to be an open circle. Now, I'm going to erase a little bit. That math was under here. It was in the way. This is a quadratic, so this one's a little bit different. This is not a line that we can just look at the slope and just construct it. So what I will need to do here is I'm going to fill in the 3 to find out where the open circle is. So I'm going to plug in the 3 here. So I'm going to have 3 something. Let's plug in the 3, 3 minus 5, and that's squared plus 1. That's -2 squared, which is 4 plus 1, that's 5. So at 3, 5, I have an open circle. And that's okay. I have open circles both of those places. That's fine. It just means there's a break in the graph right there. The domain's going to be really interesting. So let's do, I don't know, let's do 4. Let's do 5. Let's plug in a 5 right here. So we're gonna do 5 something. So we're gonna do another ordered pair with 5 as the X value. 5 minus 5 is 0. 0 squared is 0. Plus 1 is 1. So I have another ordered pair at 5, 1. 5, 1 is here. So just put a dot there, a point there. Let's do 6 and see what we get for that. We just need to do a few ordered pairs so that we know what this parabola is doing. I think this is where it turns, but let's make sure. 6. Okay, 6 minus 5 is 1. 1 squared is 1. 1 plus 1 is 2. So my ordered pair is 6, 2. So it looks like it starts coming back up right there. Let's do one more. Let's do 7. 7 minus 5 is 2. 2 squared plus 1, that's 5. So let's see, 7, 5 is right here. Okay, so this is a parabola. We know that because of the way the equation is. So let's just sketch this parabola, part of it. We'll go something like that. All right, so that's our piecewise. Now, this one's weird because of the domain. Domain. I have one interval from -infinity to, what is that, -5. -5 is included. And then I have another one from -3, and it's included. to, that's positive 3, and it's not included. And then the last one is positive 3, positive 3, sorry, positive 3, and then that one goes to infinity. So that was a crazy domain. Range, it starts at negative 2. That's included. It does end up going forever. One of them does end up going forever, so that is infinity. I'm going to do a separate video with 4, 5, and 6, and you can watch it if you want, or you can work that on your own and then go through and check your answers. I might also share the key, we'll see. So I wanted to look at number 7 to talk to you about evaluating functions. So here's what we have to do, just like with the horse hauling thing where the person said, well, I want my horse hauled to Knoxville. Okay, that's 240 miles, so that fits in the $1 per mile plus 50. So you have to figure out where the number fits in order to evaluate it, in order to evaluate the value of it. So if I've got this f of x and I've got this piecewise function, these are my two functions. These are called domain restrictions right here. And then I'm asked, what is f of 2? Well, I'm going to plug in a 2, but I got to figure out where to plug it in. I'm either going to plug it into this function or I'm going to plug it into this function. I got to figure out where it fits. So, does 2 belong in this domain restriction or this one? Well, is 2 less than negative 2? No. Is 2 greater than negative 2? Yes. So it belongs in this one. So I'm going to plug in my 2 right here. So that would be negative 2 times 2 plus 5, and that equals 1. So f of 2 equals 1. F of 4, where does that fit in? Well, 4 is greater than negative 2. So it's going to plug into this one, the same one that the 2 plugged into, because 4 is not less than negative 2. So plug in a 4 here. That's going to be negative 2 times 4 plus 5, and that is negative 3. Okay, and then the last one is negative 2. Well, that one fits into the top function because it's less than or equal to itself. So let's plug in a negative 2 right here. Negative 2 plus 3 equals 1. So f of negative 2 is also 1. So that's all evaluating is. Now, you might see the graph and it might ask you, what is f of whatever? So if you did, so let me get to a one that's a little bit cleaner. So if I asked you, if I said, look at this graph, just look at the graph, don't look at the functions up here, and I said, what is f of 8? Well, what you would do is you would go over to the 8 on the x-axis, and you would see where it actually meets up with part of the graph. So f of 8 would be 5, because that's where it meets up with the graph. Well, I could also fill it in. I could also plug it in. F of 8 was 5. So let's go up here and figure out where 8 goes. Well, 8 goes right here with this domain restriction greater than or equal to 4. If I plug that in here, negative 3/4 times 8 over 1 plus 11, that's a 1, that's a 2. Negative 3 plus 2 is negative 6, plus 11 is 5. So I could figure that out in two ways, looking at the graph or looking at the actual function. Here's the problem. Sometimes the graph is not precise and you can't really tell where f of something is. So if I said, what is f of 2? Well, it's really hard to tell if it actually went through that 2 or if it's kind of beside it. So the most accurate way to do it is going to be to look at the function itself. A lot of times, though, you can see on the graph where the point is. Let's say f of 6, we can't tell what that is because we don't know what that fraction is. But f of 4, we know what that is. It's right here at 8. So sometimes you can tell from the graph and sometimes you can't. But that's how you would do that if it asked you from the graph. So I'm going to stop here because we're at 30 minutes. I'll do a separate video with, 4, 5, and 6, and then I can also go through 8 and 9, but I won't require those, but you do still have to finish out the notes. So you're required to do 4, 5, and 6, but you can use that video to check your work, or you can follow along with me, or you can just do the work yourself. It would benefit you, however, to at least check and see if you did it right.